Hello everyone, welcome back to my channel Edu Science. My name is Prashanti. In the last class, we have covered topics like physical change, physical reaction, chemical change, chemical reaction, what is an atom, molecule, and ion. We have also gone to activity 1.1. As per activity 1.1, magnesium ribbon burns with a dazzling flame and changes into a white powder, which is magnesium oxide. Today let us see activity 1.2 and 1.3. However, before that let us represent activity 1.1 in the form of an equation, in the form of word equation. So when we talk it is lengthy, right? So to write it small, we can just write it in words and we call it as word equation. I would request you to take a pen and paper and write it along with me. So here, as per activity 1.1, magnesium and oxygen, they are written on LHS, that means left hand side, because they are reacting. They are called as reactants. So two reactants, they are separated by a plus sign which states that they are combining or reacting. So they yield, produce or gives rise to a product which is written on right hand side, which is RHS. So two elements, they react, which we call it as reactants. They are separated by a plus sign and are written on left hand side, and there is an arrow which is between reactants and products. The arrow shows the direction of the reaction, and that shows what reactants has yielded. And here in this case, magnesium and oxygen give or yield or give rise to or produce magnesium oxide, which is a product. Now today let's look into activity 1.2. It says take lead nitrate solution in a test tube. Lead nitrate solution, that means you're taking the chemical lead nitrate and adding water to it and then making it a solution. So you take the solution in a test tube and then add potassium iodide solution to this. The same thing. You take a potassium iodide chemical, add water to it and make it a solution. So it says what do you observe? When lead nitrate solution is mixed with potassium iodide solution, so what do you observe? Let us write this in the form of an word equation and then we'll see what it will happen. So as per activity 1.2, lead nitrate is reacting with potassium iodide solution. So here lead nitrate and potassium iodide are reactants and they are separated by plus sign and they are written on left hand side. Now the arrow represents the direction of the reaction. That means these two react and yield or produce or gives rise to a different product, which we write it on right hand side and we call them as products. So here lead nitrate reacts with potassium iodide and yields lead iodide and potassium nitrate. So in this we receive lead iodide is a yellow color precipitate. So when potassium iodide is mixed with lead nitrate, we can see the reaction changes into, or the test tube changes into yellow. The things in the test tube change into yellow in color. So the yellow color residue or precipitate which we see is of lead iodide, because potassium nitrate is soluble in water, so it get dissolved. Again, here we are getting two products, that's why even the products are separated by a plus sign. So in activity 1.2, when lead nitrate solution is mixed with potassium iodide solution, when these react, they yield or produce products which are lead iodide, which is yellow color precipitate, and potassium nitrate. Let us look into activity 1.3. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? So here there is a pictorial or a figure representation of the reaction. So as per this picture, they have taken zinc granules in a conical flask and they have added dilute sulfuric acid to it. So what is happening? A hydrogen gas is getting released. Let us again represent this in the form of word equation. So in this activity, zinc and dilute sulfuric acid are the reactants. So they are written on left hand side. When dilute sulfuric acid is poured into zinc granules, They react very fast and hydrogen gas is released. So that's what it says. These two reactants yield, give rise to or produce two products, which is zinc sulfate and hydrogen gas is released. They're separated by a plus sign, and these are products which are written on right hand side. In this reaction is very quick and fast. As soon as sulfuric acid is put in zinc, we can see bubbles. The bubbles are of release of hydrogen gas, and the reaction is so quick that it produces heat. So when you touch the conical flask, you can feel it is hot. So let us get back to textbook. It says from the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. So to confirm that a chemical reaction has taken place, these things must happen. Either change in state or change in color. In activity 1.2, we have seen that yellow color precipitate is formed from a colorless solution. Then evolution of gas. So in the recent activity 1.3, we can see that hydrogen gas is released and the temperature, there is a change in temperature. So these all things confirm that there is some chemical reaction which is taking place. Then we can write these equations in the word format which I have already taught you. Next, let us see how we can represent it in symbols. So let us use the chemical formula and write the above three equations, or the let us represent above three activities in equation format. So in activity 1.1, let us use chemical formula instead of words to represent this equation. So here you can see magnesium formula is Mg or symbol is Mg, and oxygen is represented as O2, and the product magnesium oxide's chemical formula is MgO. Now this equation is not balanced. We'll learn balancing of equations tomorrow. For now, this is just the symbolic representation of the equation, and we call it as a skeletal equation or skeletal chemical equation. Now, if you don't know the chemical formula of magnesium oxide or the products which the reactants gives rise to, then let us see how to write them. So here, magnesium oxide. I'm sure you have learnt in 9th standard how to derive chemical formulas. Here, magnesium oxide has two elements which are magnesium and oxygen. So let us represent first the symbols of these two elements. Magnesium symbol is Mg and oxygen is represented as O. It's just the symbol, not the molecular formula. Now, what are the charges of magnesium? Magnesium is 2 plus and oxygen is 2 minus. Oxygen in the periodic table, it is on the 8th position and magnesium on 12th. So magnesium charge is 2 plus and oxygen charge is 2 minus. Now the charges are interchanged. Here the charges or the valencies of both the elements are interchanged. So we will get an equation as we get a chemical formula of the compound as Mg2O2, but because both are same, we can directly write it as MgO. Hence here Mg plus O2 yields or gives rise to MgO. Now the balancing of this we can learn tomorrow. Now let us see the activity 1.2. The reactants here are lead nitrate and potassium iodide. Let us write the chemical formula, but first let us learn how to derive it. Here in lead nitrate, lead is represented as Pb plumbum and nitrate is NO3. The charge of lead here is 2 plus and NO3 it is 1 minus. So when we interchange the charges or valencies, so here nitrate is represented as NO3 and its valency is -1. So lead is, when the valencies are exchanged or the charge is exchanged, lead is Pb and nitrate NO3. Because the lead charge is 2, we have to put a bracket and put 2 below it. So the lead nitrate formula is PbNO3 whole twice. Let us derive the formula of potassium iodide as well. So here potassium iodide, potassium is represented symbol as K and iodide, iron symbol is I. Potassium has one positive charge, iodine has one minus charge. We have to interchange these valencies. So hence here the potassium iodide symbol is Ki. Now let us go and derive products chemical formula. So here again lead iodide, which is an yellow precipitate. Lead formula is Pb, plumbum, and iodine formula, sorry, symbol is I. Lead has 2 plus as its valency or charge, and iodine has 1 minus as a charge. So when we interchange the valencies, we get the chemical formula of lead iodide as PbI2. Now let us move to potassium nitrate. So here the potassium symbol is K, nitrate is represented as NO3, that charges potassium is +1, nitrate is -1. When we interchange the charges, potassium nitrate, we get the formula, chemical formula as KNO3. So this is how you, if you don't know the chemical formula, you can derive it. So the equation is lead nitrate PbNO3 whole twice plus potassium iodide Ki yields lead iodide PbI2 plus potassium nitrate KNO3. Now this is a skeletal equation. It is not balanced. Let us learn the balancing tomorrow. Now the next activity is zinc reacts with dilute sulfuric acid and yields zinc sulfate and hydrogen. Zinc, we know it's represented as Zn, and sulfuric acid is H2SO4. Let us see how you can derive it. So sulfuric acid is H2SO4. It has sulfur and hydrogen in it. The sulfate and hydrogen in it. The symbol of hydrogen is H and sulfate is SO4. The valency of, or the charge of SO4, is 2 minus and hydrogen is 1 plus. So when we interchange, we get sulfuric acid formula as H2SO4. So zinc is the symbol is Zn, which reacts with H2SO4, and now we get the products as zinc sulfate and hydrogen gas is liberated. So hydrogen gas, we know it is represented, molecular formula of hydrogen is H2, and let us see how to write zinc sulfate. So here zinc is Zn and its charge is 2 plus, and sulfate is represented by SO4 and its charge is 2 minus. Let us exchange its charge. So here the reaction is represented in chemical formula as Zn plus H2SO4, which is sulfuric acid, yields or produces or gives rise to zinc sulfate, which is ZnSO4, and releases hydrogen gas. So that's all for today. Let us see what we have learned. So today we have learned how to write a word equation. Reactants are placed on the left hand side and products on the right hand side. These are separated by an arrow which directs towards the products. The reactants are separated by a plus symbol which indicates combining, and the products, if they have more than one, they are also separated by a plus symbol. So in the activity 1.2 today, lead nitrate solution when combined with potassium iodide solution, which are reactants, they yields or produces or give rise to products which are lead iodide, which is yellow in color, we can see yellow precipitate, and potassium nitrate, which is soluble in water. So they're represented by PbNO3 plus Ki yields PbI2 plus KNO3. The equation, it is not balanced, we call it as skeletal equation. Then the last activity is zinc reacts with dilute sulfuric acid, which are reactants. They produce or yield products which are zinc sulfate and releases hydrogen gas. So today we have covered how to write chemical equation in the symbolic form and also in the word format. But tomorrow we will learn how to balance these chemical equations. Thank you all for today. Please like, share and subscribe. And if you have any doubts, please write in the comment section. I would try to solve them. Thank you.